Let's solve polynomials. We're going to look at what does it mean to solve a polynomial, how many solutions will a polynomial have, how do we solve them, what is multiplicity. We're going to learn about two new theorems, find all the zeros, real and imaginary, and if I give you the zeros, we'll learn how to write a polynomial. So what does it mean to solve a polynomial? It means that you're trying to find the x-intercepts. So we're looking at the x-axis. This one would have 1, 2, 3, 4 solutions. X-intercepts can also be called roots, solutions, and zeros. So let's take a look at how many solutions a polynomial might have. In my first example, this is a straight line. So if I set that equal to 0 and solve it, I'm going to get 2. This would be a first degree. There's 1, 0. My x-intercept is 2, 0. In the second example, that is a perfect square trinomial, so I can factor that to x minus 3, whole thing squared. If I set it to 0, I get x to be 3 and x to be 3. So this is a second degree. There are technically 2 zeros. We're going to call this a repeated answer because it is the same number. So the x-intercept is 3, 0. In our next example, we're going to factor out a GCF. So I have x and then x squared plus 4. I'm trying to solve it. So I set it equal to 0. So this x equals 0. And then when I solve this second part, I set that to 0. I subtract over and I get a negative 4. When I take the square root, I'm going to have plus or minus 2i. So here we have a third degree, and we have 3 zeros. 1 is real, and 2 are imaginary. My x-intercepts, my solutions would be 0, 0. Technically, 2i is not an x-intercept, but that would be our zeros. In our last example, that's a difference of 2 squares, so I can factor that to x squared minus 1 and x squared plus 1. This one factors further to x minus 1 and x plus 1. So I know I have an answer of 1 and negative 1. When I solve this, I'm going to get x to equal plus or minus I. This is a fourth degree, so it's going to have 4 zeros. In this case, 2 real and 2 imaginary. My real x-intercepts are 1 and negative 1. And then I have plus or minus I. So when you're thinking about how many solutions a polynomial will have, you have to look at your degree. The degree equals the total number of solutions, real and imaginary, together. So how do you solve a polynomial? I would start by factoring if possible. It won't always be possible, but it's a good first step. This one has 4 terms, so I'm going to factor by grouping. I'm going to take out the x squared, and we have 5x minus 1. I'm going to take out a negative 4 for another 5x minus 1. 5x minus 1 is my GCF. That leaves behind x squared minus 4. I'm going to factor fully. This is a difference of 2 squares, so we have 5x minus 1. X minus 2, x plus 2 equals 0. Using the zero product property, I could set each of those factors equal to 0. So x here is 1/5, 2, and negative 2. It's a third degree, and I had 3 real answers. But what if it's not factorable? If it's not factorable, it's going to be a little bit longer of a process. You're going to use your calculator to graph. Then you may have to use synthetic division, and if it's still an x squared, you'll have to use the quadratic formula. So let's look at this. Here we have an x cubed, so I know that I should have 3 answers. I'm going to start by graphing it on my calculator and look for integer zeros. So go ahead and enter that under y equals. You should get this graph, and I'm not sure what's happening right there and right there. I don't know if it really goes through negative 2. And I'm not sure there. So I have to look at my table. So second graph is bringing up table. And here I can see I am, in fact, at an integer negative 2. And then it maybe that looks like an integer here, but there's no other y is 0. So the only integer answer I see is when x is negative 2. So I'm going to start with that. So we're going to do synthetic division with negative 2. So I'm going to divide with actually the negative 2, because that is the 0. I'm going to set up my synthetic division, drag that number down, multiply, add down, multiply. We get 22, add down again, we get 3, multiply, and I get -6, and I get 0. This here, my remainder is 0. That has to be 0, so it's kind of a check along the way. So remember, I started with an x cubed. This is now an x squared. So from here, we can now go over to the quadratic formula. So we're going to do the quadratic formula with what was left over from dividing. And when I do that, I get x equals -b, so that would be positive 11 plus or minus a -11 squared minus 4ac all over 2a. X equals 11 plus, that will be 121 minus 120 all over 20. So x becomes 11 plus the square root of 1, which is 1 over 20. X is 12 over 20, which simplifies to 3/5, and x is 10 over 20, which simplifies to 1/2. So my three answers are 3/5, 1/2, and the original -2. I check my degree, it's 3, so I did find all three answers. What is multiplicity? So when we look at the shape of the graph at the x-axis, that's going to help us figure out how many answers we have. If it goes straight through, right there it goes straight through, that's just going to be one answer. There's another one over there. If it's tangent, so it touches and bounces off, then this is going to be 2 answers. It's a multiplicity of 2. We don't say there's a multiplicity of 1. This is a multiplicity of 2. And then this one, it curves through at -3. So we would say this is a multiplicity of 3. It represents -3 and -3 and -3. And we could use all of those answers in synthetic division if we needed to. So multiplicity is having repeated answers. Let's try to solve this polynomial. The first thing I'm going to do is graph it. So enter it under y equals, and then check your table. So I end up with this, kind of similar to the last one. I need to see if that does in fact go through -1, and I need to see what's happening, or sorry, -2, and I need to see what's happening here. So -2, 0 is an x-intercept, and then I do see 1, 0. So y is 0, and it happens to be tangent there. So I know that I have -2, +1, and +1. I have 3 x's that I can start with. This is a 5th degree, so I have to find 5 total answers. So I'm going to synthetically divide with -2, 1, and 1. We're going to build off the synthetic division of each other, and you can do it in any order. So I'm going to start with the -2. 1, we do need a placeholder of 0, and then a 1, 2, -12, and 8. Drag down my 1, multiply -2, add down -2, multiply 4, add down 5, multiply -10, -8, 16, 4, -8, 0. That's my remainder right there. I need that to happen. If you don't get it, go back and check your work. Now I'm going to build right off of that. I don't need to rewrite it. Those will be the coefficients that I'm dividing into. I'm going to divide by 1, drag down 1, multiply 1, add -1, multiply, add, multiply, add, multiply. And this last one is my remainder. It's going to be indented because I'm not dividing into that remainder. And I had another check. And we can synthetic divide again by a 1. 1, 1, 0, 0, 4, 4, 0. This started out as an x to the 5th, went x to the 4th, 1 degree less. So that means I'm at x squared. So now I have x squared plus 4 equals 0. I can solve that by subtracting over the 4, and then I get x to be plus or minus 2i. So in this case, I have 2 imaginary answers and 3 real answers for all 5 total answers. Let's look at 2 new theorems. We have the irrational root theorem, It says if a plus the square root of b is a root, then a minus the square root of b is also a root. Something like if I had 2 plus root 3, then I know that 2 minus root 3 is also an answer. They come in pairs. The same thing is going to be true with imaginary and complex numbers. The complex conjugate theorem says if a plus bi is a root, then a minus bi is also a root. So we have 4 plus 5i. If I know that's an answer, then 4 minus 5i is also an answer. Given the zeros, write a polynomial. So if I tell you that you have a polynomial with a 0 of -1 with a multiplicity of 2 and 3i. So a lot of things you have to pull out of there. First we have multiplicity. We also have this imaginary number. So that means if I have -1 with a multiplicity of 2, that means I have -1 and -1. And if I have a 0 that's 3i, that also means, applying the complex conjugate theorem, that I have a 0 that's -3i. So this is going to be a 4th degree. Those are my zeros, and I'm going to just work backwards. I'm going to write them in factored form. So I'm going to do x plus 1, remember to change the sign, and then x minus 3i and x plus 3i. Remember to keep your imaginaries together when you're multiplying. Don't do the 1 and the 3i together. It's going to get quite messy. And then also if you end up doing those two middle ones together because maybe you forgot to include the -3i, then it might tell you that you have a mistake. So I'm going to multiply these, and then I'm going to multiply those. So this becomes x squared plus 2x plus 1. This one becomes x squared. My middle two terms cancel out. Minus 9i squared, which really becomes x squared plus 9. Now I'm going to multiply out this giant thing. So I'm going to distribute, and I get x to the 4th plus 9x squared plus 2x cubed plus 18x plus x squared plus 9. And then when I simplify that, combining like terms, I get a polynomial that is x to the 4th plus 2x cubed plus 10x squared plus 18x plus 9. So it is a 4th degree. It's a polynomial that has all of those for zeros. And to recap, when you are asked to solve for polynomials, you should find all the solutions, real and imaginary. Try factoring first. If it's not factorable, use your calculator to find some zeros. Do synthetic division, then possibly use the quadratic formula. Check the shape of the graph. It might be tangent and you have 2 answers. It might curve through and you have 3 answers. Remembering that multiplicity does mean repeated answers. And also remember, imaginary and irrational numbers come in pairs. Nice job.